Service discovery in Kubernetes is a fundamental concept that enables pods to locate and communicate with services efficiently. In a dynamic container environment where pods can be created, destroyed, and moved around frequently, having a reliable mechanism to find services becomes essential for application functionality. Service discovery addresses a critical challenge in Kubernetes. Pods are ephemeral, meaning they can be created and destroyed at any time, and each time a pod is recreated, it gets a new IP address. This makes it impossible to rely on static IP addresses for communication. Service discovery solves this by providing an automatic mechanism that allows pods to locate and connect to services without needing to know their exact IP addresses. Every Kubernetes cluster comes with an internal DNS service built in. The default DNS server is called CoreDNS. CoreDNS acts as the backbone of service discovery by automatically resolving service names to their corresponding IP addresses. When a pod needs to communicate with a service, it simply queries CoreDNS using the service name, and CoreDNS returns the appropriate IP address. Kubernetes DNS follows specific naming patterns that make service discovery straightforward. If you're accessing a service within the same namespace, you can simply use the service name. For cross-namespace communication, you append the namespace to the service name, separated by a dot. The fully qualified domain name, or FQDN, includes the service name, namespace, and the cluster domain, which is typically svc.cluster.local. This hierarchical naming structure provides flexibility and clarity in service addressing. Let's look at a practical example. You can test DNS resolution by running the kubectl exec command to execute an enslookup query from within a pod. When you run kubectl exec-it my-pod-enslookup my-service, the DNS server returns the cluster IP address associated with that service. This allows the pod to establish a connection to the service using its cluster IP. Kubernetes offers two primary methods for service discovery. The first method uses environment variables, which are injected into pods at creation time. This is considered a legacy approach and has limitations because the variables are only set when the pod starts. The second and recommended method is DNS-based discovery. DNS provides dynamic resolution at runtime, which means pods can discover services even if those services are created after the pod starts. This makes DNS the preferred choice for modern Kubernetes applications. Headless services are a special type of service in Kubernetes that don't have a cluster IP. They are created by setting the cluster IP field to none. Instead of returning a single service IP address, DNS queries for headless services return the individual IP addresses of all the pods backing that service. This is particularly useful when you need direct pod-to-pod communication, or when working with stateful applications that require direct access to specific pod instances. When you need to access a service that exists in a different namespace, you must specify the namespace in your DNS query. For example, to connect to a database service in the production namespace, you would use database.production.svc.cluster.local. This cross-namespace communication capability allows different parts of your application to be organized into separate namespaces while still being able to communicate with each other. Understanding the DNS resolution flow helps clarify how service discovery works end-to-end. First, a pod queries a service by its name. This query is sent to CoreDNS, which resolves the service name to its cluster IP address. Once the pod receives the cluster IP, it can send traffic to that address. The service then routes the incoming traffic to one of its backend pods using load balancing. This entire process happens transparently, allowing developers to focus on application logic rather than networking details. Let's explore some common DNS patterns you'll encounter in Kubernetes. For a web service in the same namespace, you can use the simple format http://web-service:80. When accessing a database in the default namespace from another namespace, use postgres.default. For clarity and to avoid ambiguity, especially when working with external services, you can use the full FQDN like api.external.svc.cluster.local. For stateful applications using stateful sets with headless services, you can address individual pods directly using pod-0.statefulset. When service discovery isn't working as expected, there are several troubleshooting commands you can use. To test DNS resolution, run kubectl exec-it pod-nslookup service-name to verify that the service name resolves correctly. To check if a service has backend pods registered, use kubectl get endpoints service-name. This shows you which pod IPs are currently associated with the service. Finally, verify that CoreDNS itself is running properly by checking the pods in the kube-system namespace, using kubectl get pods-nkube-system-lk8s-app equals kube-DNS. Let's recap the key takeaways about service discovery in Kubernetes. DNS is the recommended and most flexible method for service discovery in modern Kubernetes clusters. When accessing services within the same namespace, you can use simple service names without any additional qualifiers. For cross-namespace communication, always include the namespace in your DNS query to ensure proper routing. Headless services provide a special mechanism for direct pod IP access, which is essential for stateful applications and scenarios requiring pod-to-pod communication. Mastering these concepts will enable you to build robust, scalable applications on Kubernetes.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.